What's up, scholars? All right, last time we talked about proving parts of triangles are congruent if we know those triangles are congruent. This time we're going to talk about some really special aspects of special types of triangles, like isosceles and equilateral and right triangles. Okay, let's remind ourselves which of each of those are. Isosceles means we got two sides that are the same. And equilateral means all three sides are the same. And a right triangle means we have one right angle. Alright, let's talk about them. We got this base angles theorem says that if two sides of a triangle are congruent, like in this picture over here, AB is congruent to AC, how do we know it's got the same number of hash marks? Yes. Then the angles opposite them, who's that them talking about? Well, it's talking about the two sides of the triangle that are congruent. There's a name for that word referring to previous words. What is that word, I wonder? So let's write that out in symbols. That's like saying if segment in a triangle, segment AB, is congruent to AC in triangle ABC, then angle who? Angle B is congruent to angle C. These angles down here at the bottom. That's pretty nifty. Doesn't matter how long these are, as long as these are congruent, those bottom angles, those base angles are going to be congruent. That's why it's called the base angles theorem. If our math people were not very clever with our naming, we pretty much tell you exactly what we're talking about. So it's the base angles theorem. I'm talking about the base angles. When you have base angles, you only have base angles in an isosceles triangle. Genius. Alright, we know that converse means you flip it. So we're going to take this sentence up here and flip it to get the converse of the base angles theorem. So we're going to say if angle B is congruent to angle C, then segment AB will be congruent to segment AC, right? If two angles of a triangle are congruent, like B and C are congruent, then the sides opposite them, those two angles, the sides opposite those two angles are also congruent. They're opposite. So let's write it out in symbols. If angle B is congruent to angle C in triangle ABC, then segment AB will be congruent to segment AC. Nice. So we proved this by measuring it previously. Hopefully you did that activity where you measured these like I asked you to. If you didn't, shame on you, go back and do that. But we're going to prove it together in this next example. Use the diagram of triangle ABC to prove the base angles theorem. What did the base angles theorem say? It said if the sides are congruent, then the base angles will be congruent. So we're given this diagram where AB is congruent to AC and segment AD bisects. What's bi mean? Two. So this bisect means splits in two congruent parts. Segment AD bisects angle BAC. Those are our givens. So what's the reason for them being written down here? Because they're our givens. Duh. That's given, son. What are we trying to prove up here? Well, we're trying to prove that angle B is congruent to angle C. So let's think about this for a hot second. We got these two sides that are congruent. We got this bisected situation happening. What's bisect mean? He said it splits in two congruent parts. So that's going to mean that this angle right here is congruent to this angle right here. Gosh, I wish that line was totally straight, but it's not. But in our minds it is. In our minds, it's totally straight. So let's just make it so. I have a straight edge. I bet you do somewhere. Let's live our best life. Let's make that segment. There we go. Ha! Ha! Perfect. Alright. That bisector means those angles are congruent. I'm trying to prove that some part of some triangle is congruent to some other part of some triangle. You guys see those two triangles right here? Well, how are we going to do that? We're going to use our congruent parts of congruent triangles are congruent. So first we're going to prove these triangles are congruent. We have a pair of sides already. We have a pair of angles already. And then we got this thing down the middle that they're sharing. So that's going to be congruent. And then we'll have two triangles that are congruent. How come? By side, angle, side. And then we'll know that they're corresponding parts. B and C are congruent. So let's write down all the things we just said. Because we kind of went through that proof before we did the proof. We did a little proof planning. Right? Cool. We wrote down our givens. Next we got to talk about what it means that AD bisects angle BAC. Well, if it bisects, the definition of an angle bisector, splitting into two congruent parts, is splitting into two congruent angles. So this means angle who? Angle, let's get some colors up in here. B, A, D, that angle bad, is congruent to this angle CAD. Man. Angle bad. Congruent to angle CAD. Oops. CAD. That's an A. That's totally an A. So we did that, remember, and then we're like, oh, well, we split this down the middle perfectly because it said so. Bisects, splits into two congruent parts. And now we have this shared segment between these two triangles. And when you are the same as yourself, you're congruent by the reflexive property. So that means segment AD is congruent to segment AD. And then we really have congruent triangles, man. This whole blue triangle, straight up congruent to the red triangle. It's not just those angles that are congruent, it's the whole dang triangle. Why? Side angle side. So now we got triangle bad, all congruent. Whoa. The triangle CAD. I really don't like making that A, do I? Sweet. So then why is angle B congruent to angle C? Why not B congruent to, I don't know, literally anything else? Well, if we look back at our congruent statement and we check out our order, also we look in our diagram to make sure, smell check, make sure it makes sense. B is the first letter, C is the first letter. These guys are definitely corresponding parts of these congruent triangles. These are corresponding parts of congruent triangles, which are what? Congruent. CP, CT, C. So now we know absolutely 100% for sure that the base angles theorem is true. We used our measuring tools and we did a proof. So we know beyond a shadow of a doubt this is accurate. Alright, well, what can we do with this? Using the base angles theorem, we can draw in several congruence marks in the diagram on the left. Using its converse, we can draw in several congruence marks in the diagram on the right. Whoa. Whoa. Let's see what we can do. Base angles theorem says if you have two sides that are congruent, two sides that are congruent, then the opposite angles are congruent. Well, you're congruent to you. Let's try again. Now we've got, who do I want to cover up? I want to cover up, sure, just barely. We have two sides that are congruent, so they're opposite angles. Base angles are congruent. Two sides are congruent. So that means this angle down here, and that's opposite this one, is congruent to this opposite, which is up at the top. Look. We also knew this from what? Well, we talked earlier about how equilateral triangles are always equiangular. And those are all going to be 60 degrees. Because if they all add up to 180 and you divide it by 3, then they're 60 degrees. So I bet you can guess what's going to happen over here. Using our converse, we've got two base angles that are congruent, so they're opposite sides. Opposite of u is u, opposite of u is u. Those are congruent. And similarly, let's cover up this one. That's working. Two angles are congruent, so their opposite sides are congruent. And I'm using the same number of congruence marks for everybody. And look at that. I would posit that these are congruent triangles. Pretty sure, 100% copy pasted that one to that one. So, yep. Yeah. Sometimes we talk about corollaries. These are statements that can be easily proven using a theorem or a definition. They kind of logically follow from that theorem. So the corollary to the base angles theorem says if a triangle is equilateral, meaning all of its sides are what? Equal sides, then it's equiangular. It's got equal angles. And corollary to the converse is actually going to be the converse of this corollary. Whoa, we could call this the converse of the corollary of the base angles theorem. Would also be true. If a triangle is equiangular, all its angles are equal, then its sides are all equal. It's just how it be. You know. See what we can do about that. Oh man, let's solve some triangles. I love solving some triangles. This is good stuff. Good stuff. Okay, let's check out example number 1. You know what? I'm going to leave this one to you. These are so fun. I'm going to leave this one to you. You're going to get it. I feel good about it. Show me when you're done. Get you some points. So far, we've learned 4 ways to prove the triangles are congruent. They are what? What are your letter combos? Give them to me. We got side, side, side. Side, angle, side. Angle, side, angle, and angle, angle, side. I kept wanting to put angle, side, side. That would be really funny, but there are no buts allowed in geometry, so that one doesn't work. There's one more that you might have noticed on your study guide, the last test. No, you probably didn't. We didn't talk about it yet. But I think it was mentioned in there somewhere. Hypotenuse leg is another way to show that triangles are congruent. And we can only use it if we have a hypotenuse and a leg, which means we're working with what kind of triangle? It's a right triangle, man. It's the only one you have a hypotenuse with. This says, if a hypotenuse and a leg of a right triangle are congruent to the hypotenuse and the leg of a second triangle, then the two triangles are congruent. There's a proof on this page if you want to see it. It's pretty tough. So if you think you're pretty tough, you should check it out. So, if the hypotenuse and the leg, a leg of a right triangle, so we have to have a right triangle, we have to have a hypotenuse congruent, and we have to have a leg congruent, could be either one, then the two triangles are congruent. So, triangle ABC and triangle DEF our right triangles. There